What's up, friends? In this video, I am going to go over the Unit 3 review solutions to prepare you for your test this week on radical functions. Let's get to it. So, number one, we want to write the expression in radical form. To write the expression in radical form, whatever my base is, x, becomes my radicand. Whatever my denominator is becomes my index, and whatever my numerator is becomes my exponent here. So x to the 4/5 is the same thing as the 5th root of x to the 4th. Our next problem, we're going to do the opposite thing. Instead of going from exponential to radical form, we are going from radical form to exponential form, and it has the same rules. So we are going to keep our radicand and write that as our base. But what would our exponent be for this? What would our rational exponent be? Well, we have to use the invisible exponent and index here. So if my variable doesn't have an exponent, we assume that the exponent is just 1, right? Y to the first is just y. And then if this is a square root, the hidden index is 2. So use the same rule that we used in our last slide. If we have the square root of y, that can be written as y to the 1/2. All right. Now for this type of problem, we are going to use our laws of exponents. And in particular, this law shows that if we have x to the m, and that is all taken to the power of n, right? We have another variable as an exponent on the outside, then we can multiply our exponents together to get x to the power of m times n. So this is x to the 3/4 times 2/3. And you can reduce ahead of time, or you can just multiply across. However you like, do whatever you are most confident with. So I am multiplying my numerators. 3 times 2 gives me 6. 4 times 3 gives me 12. This is x to the 6/12. And I'm looking at my options over here. The question asks, which of the following are equivalent expressions? Now, none of these have x to the 6/12, but we do see some options in radical form. So I am going to start by converting this to radical form to see which one of these is an equivalent expression to x to the 6/12. Following our rules, our base becomes our radicand, our numerator is our exponent, our denominator is our index. So an equivalent expression would be A. Also notice that we can reduce this fraction 6/12. 6 goes into itself once, 6 goes into 12 twice, so this would reduce to x to the power of 1/2. So B is an equivalent expression. We already know C can't be because we've converted it into radical form already. But then we have two other options here. It definitely can't be x squared. X to the 1/2 is not the same thing as x squared. But check it out. If I convert x to the 1/2 into radical form, keep the base, right? That is your radicand. Exponent 1, index 2. And as you saw from our previous problem, anytime you have like the square root of x to the first, that's just the square root of x. So our final answer is A, B, and D. My recommendation when you take this test is to check both exponential form and radical form before and after simplifying the expressions to find the equivalent forms. All right, now this problem wants us to multiply 5 to the 2/3 times 5 to the 5/6. And this uses the property, the law of exponents, that anytime we are multiplying something with the same base, we keep the base and we add our exponents. So note how this is different compared to the last problem. We are going to add the exponents, keep the base. So check it out. keep my base, which is 5, add 2/3 plus 5/6. Now some work for adding fractions. I need to make sure that I have a common denominator. So let's try to make this 3 into a 6. I am going to multiply both numerator and denominator by 2 so that I have 5 to the 4/6 plus 5/6 equals 5 to the 9/6. I can reduce this even further because 3 goes into both 9 and 6. So our final answer here in exponential form is 5 to the 3/2. Simplify 343 to the 2/3 power. Ooh, that looks crazy. I don't know that off the top of my head. I don't know about you guys. So when we see something like this, that is our hint to convert to radical form. So I am going to, again, keep my base. That becomes my radicand, 343. And this would be the cube root of 343 squared. Life hack, do this first. Find out what the cube root of 343 is. And there's several ways to do this. You can use a calculator if you want, but if you aren't really sure what to do, you can always just like break it down like we used to. So 343, test some numbers that you think might go into it. I personally already know that 7 can go into it. So 7 times 49. And then I can break down that 49 into 7 and 7. Because this is a cube root, I circle my group of 3, and there's nothing left over. So the cube root of 343 is just 7. So that means when I simplify this, my answer is 7, and then I still got to square it. So 7 squared, which is just 49. Yay! For this problem, we are going to divide, and our rules for division for the laws of exponents says that anytime well, think about this, anytime we multiply, we add our exponents. Anytime we divide, we subtract our exponents. Always keep that same base. So, if I divide these guys, I get 6 to the 1/2 minus 2/5. To add or subtract fractions, we must have a common denominator, so let's multiply them by each other. Multiply this by 2, so that I'm going to get a denominator of 10. So in order to make this denominator 10, I'm going to multiply by 5. When I do that, I get 6 to the 5/10 minus 4/10. And that is just 6 to the 1/10. And this, my friends, is your final answer. For this next problem, we want to simplify the radical that has variables on the inside. And I like to see this as like 4 separate problems. Simplify the 4th root of 64. Simplify x to the 15th. Simplify y to the 8th. Simplify z to the 3rd. So instead of like freaking your brain out and just like being like, there's so much to do, just do like one step at a time. Let's start by breaking down this 64 to find the 4th root. I can break down 64 into 2 and 32, into 2 and 16, 2 and 8, 2 and 4, and 2 and 2. Because it's the 4th root, I'm going to circle 4 of the same number, and that gets to come to the outside. It gets to break free. Woo! Comes to the front over here. Let me still write the 4th root, just in case there's going to be stuff left on the inside, you know? All right, and then we have a 2 left over and another 2 left over, so we just multiply those. That's just 4, and so that stays inside the radical. Okay, so we've broken down our 64. Now, when it comes to the variables, we use this property of division. So ask yourself, how many times does 4 go into 15? 4 goes into 15 3 times to get 12. And then I would still need 3 more x's to make 15, right? Just to kind of like show what's going on in my head here. 4 times 3 equals 12. That's how many times it goes in evenly. But my goal is 15. So whatever the leftovers are, whatever those remainders are, that stays inside. Just like how these 2's were left over, so 2 times 2, that 4 stayed on the inside. All right, how many times does 4 go into 8? It goes in twice. So I have y to the second. And there's no remainder, nothing's left over. It goes in evenly. And last but not least, how many times does 4 go into 3? Well, oh snapskis, it doesn't go in at all. So in this scenario, when it doesn't go into the exponent, it is all left inside. So our final answer here, 2 times x to the third, y to the second, times the 4th root of 4, x cubed, z cubed. Kind of fun to say, not gonna lie, big flex. Weird flex, but okay. Oh my god, who gave me this much power? All right, let's break down the square root of 48 and break down the square root of 12, because that's what we have to do in order to simplify this. In order to add and subtract radicals, we have to have like a common radicand. So the number inside the radical has to be the same in order for us to add and subtract. When we multiply or divide, we don't really care. Doesn't matter. So break down this 48 into 3 and 16. 16 can be broken down into 4 and 4. Because it's a square root, remember that's an invisible 2 when it's square roots, I circle 2 of the same number. That gets to break free to the front. And then whatever is left over stays inside the radical. So square root of 48 is 4 times square root 3. This is already fully simplified, so I'm just going to rewrite it. 5 times square root 3. And then let's break down 12. 2 and 6. 2 and 3. I have a group of 2's. It gets to break free to the front. But don't forget, that's a minus sign there. So I'm going to write minus 2, and then that 3 is left over. And it stays inside the radical. 4 plus 5 is 9 root 3, minus 2 root 3. 9 minus 2 is just 7. And then we keep the square root 3. Let's try this problem. Same process, except this time there's already a number in front, but don't let that freak you out. Check it out. We break down 18. 2 and 9, 3 and 3. It's a square root because there's nothing there, so we assume our index is a 2, and that tells us how many to circle. I have 2 of the same number. It breaks free to the outside. And I have a 2 left over that stays inside the radical. So the 3 breaks free, but there was already that 5 out there, meaning we're just going to multiply them together to get 15 square root 2. All right, let's try that same thing over here with 2 times the square root of 32. Break it down. 2 and 16. 16 is 4 and 4. I have 2 of the same number. It breaks free to the outside so that it becomes 4 times 2. Whatever's left over stays inside the radical. 4 times 2 is 8. So I have 8 square root 2. And nice! Check it out. We have 2 of the same radicands here, so I can combine it. I keep the radical 2, and I subtract 15 minus 8 to get 7. 7 radical 2 is our final answer. All right, let's get into solving. So for this type of problem, what we want to do is get this whole thing by itself first. So anything that is next to it in any way, we got to move that to the other side of the equation. So this is 2 times x minus 1 to the 3/4. I'm going to divide each side by 2 to get rid of it. This cancels out, and I'm left with x minus 1 to the 3/4, which is equal to 8. From here, it can get a little tricky, but remember, now our goal is to get rid of our rational, which is fractional, exponent by multiplying or taking each side to the power of the reciprocal. So if this is 3/4, I'm going to multiply this by 4/3 and raise this to the power of 4/3 as well. These cancel out to get an exponent of 1. And we don't need to write an exponent of 1. That's usually just invisible. So now I have x minus 1 by itself is equal to 8 to the 4/3. And this is where you may feel stuck. But remember, anytime your right side of the equation looks like this is your key to convert to radical form. So I convert by writing the cube root of 8 to the 4th. Just like we saw before, you want to take the cube root of 8 first. It'll make life easier if you're using mental math. So I have x minus 1 equals the cube root of 8, which is just 2. 2 times 2 times 2 equals 8. And then raise that to the 4th power. So this says x minus 1 equals 2 to the 4th, which is 16. I'm almost done. I just got to add 1 to each side and get x equals 17. That is my final answer. All right, solve for x. A little more challenging here, but our steps for solving are to start by isolating the radical, which that radical is already by itself. The next step would be to get rid of the square root. The opposite of a square root is squaring. So to get rid of the radical, I'm going to square each side, like this. Now, you cannot subtract 18 or 3x first. You can't do it. Anything that's inside the radical cannot be removed until you remove that radical first. So that's why we start out by squaring. And when I do that, I get x squared equals the radical and the square cancel each other out. So I'm just left with the radicand, which is 3x plus 18. Now, I need one side to be equal to 0. Anytime you see x squared, that's your hint that we're probably going to have to end up factoring here. So let's move some stuff over. I don't want to move over the x squared because then it's going to make it a negative x squared. So I'm going to move all this fun stuff to the other side. Subtract 3x and subtract 18. So we now have x squared minus 3x minus 18 is equal to 0. And again, the whole reason we did this is so that we can factor and get some answers. So ask yourself what multiplies to 18 that adds to 3. More specifically, what multiplies to make negative 18 that adds to negative 3. That's going to be 6 and 3. 6 times 3 is negative 18. If I want to make this a negative 3, I'm going to say negative 6 plus 3. Can't be the other way around. Negative 6 plus 3 gives me negative 3. Negative 6 times 3 gives me negative 18. So if my factor is x minus 6, my solution is just the opposite. X equals positive 6. If my factor is x plus 3, my solution is the opposite. X equals negative 3. And last but not least, one of these solutions may be an imposter, so it is extremely important that we check for our extraneous solutions, our extra lying solutions, by plugging our answers back into the original equations to see if they're true. All right, so let's start by checking first to see if 6 is in fact a solution. So I am going to just plug that in for x here. So I'm trying to figure out if 6 is equal to the square root of 3 times 6, which is 18, plus 18. 18 plus 18 is 36. Is 6 equal to the square root of 36? Totally. The square root, the positive square root of 36 is just positive 6. So our final answer here is 6 is equal to 6, and this is in fact a solution. Let's now test it with our other solution that we got, x equals -3. So again, plugging it into the original equation and writing parentheses every time there's an x, so I know where to plug this in. So if x is -3, I'm trying to figure out if -3 is equal to the square root of 3 times -3 plus 18. So right off the bat, we should be noticing the fact that we're saying a square root is equal to a negative, and that can't happen for this to be a function. So all right, -3 is equal to, or is it, the square root of 3 times -3, which is -9 plus 18. Is -3 equal to the square root of -9 plus 18, which is 9? Well, the positive square root of 9 is going to give us a positive 3. So what this is actually saying is -3 equals positive square root of 9 is positive 3. This is not a true statement. Therefore, x equals -3 is not a solution. Only solution we have for this is x is equal to 6. Woo! All right, now let's get into graphing. So describe the transformations from the parent function, aka the mother function, f of x equals the square root of x. And it would be helpful for us to remember the rules of the transformations here. So let's start by writing out the general equation. The general equation says g of x is equal to a times the square root of x minus h plus k, where a is the stretch or compression of the graph, h is the horizontal shift, whether it's moved left or right, k is the vertical shift, whether it's moved up or down, and if there's a negative in front, then that means that there has been a reflection across the x-axis. So take a moment and write the transformations of each function here. So I'm just going to start off with what I know. If I have x minus 2, anytime we have subtraction with the x, that is a shift to the right. It's like the opposite of what you would normally think. So x minus 2 means I am moving to the right 2. A plus 4 on the outside. Remember that k is our vertical shift, so plus 4, trust your intuition here, means we're moving the graph up 4 units. And this 1/3 in the front, representing a, anytime a is greater than 1, it is a stretch. Anytime a is between 0 and 1, so it's like a fraction or a decimal, that is a compression. So we have a compression by 1/3. All right, for our next function, remember when it was x minus 2, that was to the right 2. So if we have x plus 7, that means I'm moving to the left 7 units. If I'm subtracting 1 on the outside, remember that's our vertical shift. That means I am moving down 1. If I have a 2 in the front, that means I am stretching by 2. And that negative sign means there is a reflection. The last one's a little tricky because it's using function notation, but don't let this freak you out. Don't let this intimidate you because it's the exact same thing. So follow the same rules. With x here, if I am adding 2, just like when I added 7, that means I'm moving to the left. So this is just saying that we're moving our parent function, f of x. It's another way to write it. It means the same thing. We're moving our parent function, f of x, to the left. Oop, can't write down there, but to the left 2 units. This plus 9 on the outside means we are moving our graph up 9 units. There's no number in the front, there's no negative sign, and so these are our final answers for our description of the transformations. Now, we're going to graph the function f of x equals x minus 1, square root of x minus 1, plus 2. And your very first step should always be to graph the parent function, the mother function. 0, 0, 1, 1, 4, 2. These are the coordinates that you need to know. They will make your life so much easier. Here is the parent function of our graph. Step 2, describe the transformation based on the equation. So doing exactly what we did in that last problem. If this is x minus 1, that's telling me I'm moving to the right 1. And if that's plus 2, that means I'm moving up 2. And so the points from our parent function is exactly what we are moving. So check it out. I'm moving right 1, up 1, 2. Right 1, up 1, 2. Right 1, up 1, 2. And so our new graph will look something like, pretend that's going through that point. Something like this. So take a look at this graph. We actually just graphed the same equation here. So this is the graph of f of x equals the square root of x minus 1 plus 2. What is the domain of the function? The domain is the set of all x values. So whereabouts on the x-axis does this graph start at? We read a graph from negative to positive. And so if I'm just kind of like scanning across here, the first starting point is at 1. So my domain is going to be from 1 all the way to infinity. It goes on forever and ever. So my domain is from 1 to infinity. Infinities always have a parentheses. Because there's no open circle here, we use a bracket. All right, let's find the range. So again, we are working with the same graph. The range is the set of all y values. So we're scanning our graph from negative to positive, but in the y direction. And so looking at the lowest point of our graph first, what is the lowest point of our graph? What's the y value at that point? So it starts here at 2, and it goes up forever and ever to infinity. So that's 2 infinity and beyond. I had to, sorry, it was too easy. But yeah, your range should be from 2 to infinity. Woo. Guys, we made it! It's the last problem. So we need to write the equation of this graph. The first thing you want to do is just kind of like write what happened. What happened from the parent function 0, 0, 1, 1, 4, 2. This is what we're starting with, yeah? So then if I'm kind of looking at this new function, it looks like it's been flipped. It's been reflected for sure. So let's write that down. It has been reflected across the x-axis. my starting point is no longer at 0, 0. It has moved up 2 units to positive 2. So I've reflected across the x-axis. I moved up 2 units, and it didn't really move to the left or right. It still stayed here. So I'm not going to have any horizontal shift, but it has definitely been stretched a bit. So check it out. With our original parent function, we should have 0, 0, 1, 1. It literally just went over 1, up 1. But if we are looking down here, the parent function reflected would look something like this. But there's been a stretch of the graph. There's been a stretch of the graph. Instead of moving right 1, down 1, it's moved right 1, down 1, 2, 3. So there's been this like stretch of 3. And so once again, we're just going to use our general formula for this. If I have a stretch of 3, that means A is 3. If I reflected, that means that this whole function is going to be a negative. If I moved up by 2, that means my plus k is going to be plus 2. And then given that like nothing else happened here, like there was no horizontal shift, I'm just going to write square root of x. So the equation of our graph is y equals negative 3 times the square root of x plus 2. If you made it this far, you are a champion and you are going to crush the test later this week. I'm pumped for you. Have a fantastic day. Thanks for sticking around. Deuces. Perez out.